Welcome to this video, which is the full solution to the practice questions from lesson 13.2, two-dimensional lines, Cartesian and scalar equations. For the first question, we want to determine the slope of the line, which is perpendicular and parallel to 3x minus y plus 15 is equal to 0, and the line which is perpendicular and parallel to this vector equation, r is equal to negative 1, 2 plus t times negative 1, 2. Okay, for the very first part of this question, the equation is given to us in scalar form, and we got 3x minus y plus 15 is equal to 0. We know that when we have a scalar equation, the coefficient of x, our a value, and our coefficient of y, which is our b value, can be used to give us the normal to the line. That means the normal to our line here is going to have components 3, negative 1. So 3 in the x direction and negative 1 to the y direction is the normal to our line. So that means our line is kind of going like this. And since these are the two components, 3 and negative 1, the slope which is perpendicular to the line here is going to be rise over run, which is negative 1 over 3. And a slope of a line which is parallel here is going to be the negative reciprocal of that. Taking the negative reciprocal of a negative 1 over third, the negative cancels out, and we take the reciprocal of 1 over 3, which becomes 3 over 1, or simplified to 3. For part B of the question, we're given the equation in vector form, so the direction here is negative 1, 2. So that's negative 1 in the x direction and 2 in the y direction. So negative 1 and 2, and that is the direction that our line is traveling in. So we don't really care about the starting point here, all we care about is the direction. So the slope of the line parallel to this is going to be rise over run. So that's 2 over negative 1, which is simplified to negative 2. And a line that is perpendicular to this would have a slope which is the negative reciprocal of this. So taking a negative of this, we will get 2 over 1, and taking the reciprocal, we get 1 over 2. For the next question, we're asked to determine the vector, parametric, and Cartesian equation to the line 2x minus 5y plus 10 is equal to 0. So the form that we're given the equation is the scalar form, and this is nice because it gives us one very big piece of information based on our a and b value, which are coefficients of x and y. The normal of this line is going to have components a, b, so that's going to equal to 2 and negative 5. So that means so this normal component will have an x value of 2 and a y value of negative 5. So it's going to look something like this. So that's our normal. And our line is going to be perpendicular to this. So if the slope of this line is equal to negative 5 over 2, then the slope of our line, so this is the perpendicular line, parallel to our line is going to be the negative reciprocal of this, which is going to be 2 over 5. And that means our line here, the one that's going like this, will have a rise of 2 and run of 5, and that means its direction vector is going to be 5 in the x direction and 2 in the y direction. Again, you don't have to go through this drawing part. After understanding this graphically and conceptually, you can just look at the normal and know that if the normal is 2 and -5 in 2 dimensions, the direction vector for something that is perpendicular to that will be the negative reciprocal, meaning that we're switching the x and y and we're taking only the negative. We're changing a negative to a positive or positive to a negative. Okay, now we have the direction vector of our equation, but we also need a point. To find a point in our line, we know that our scalar form is 2x plus 5y plus 10 is equal to 0. We need to let x equal to something or let y is equal to something and solve for the other variable. The easiest value to choose is x is equal to 0. And if we use x is equal to 0, we will get 2 times 0 plus 5 times y plus 10 is equal to 0. We are going to simplify. We will get 5y plus 10 is equal to 0 because this cancels. And we're going to subtract 10 from both sides, and we will end up getting 5y is equal to -10, and therefore y is equal to -10 over 5, which is -2. So therefore we know that the point 0, -2 is on our line. Once we have this is going to be our starting point. I'm going to let it be point A, and we can start writing all our equations. In vector form, do that here, vector. We are going to start with our point, which is 0, -2. And again, this point could be any other point on the line. It doesn't have to be 0, -2. Plus some parameter multiplied by the direction vector, which is 5, 2 here. And we can right away turn that into parametric. We are going to write the equation for x and for y. For x, it is going to equal to 0 plus t times 5. That's just 5t. And for y, it's going to be -2 plus t times 2, which is 2t. Finally, for our Cartesian form, we can rearrange for t and write that down, or we can use the values right from the vector form. It's a little bit easier to use this because we already have the parametric equation. So to rearrange for t in the first one over here, we just divide both sides by 5, so t is equal to x over 5. And for the second one here, we're going to add 2 to both sides first. We're going to have y plus 2, and then we are going to divide by 2. So this is going to be y plus 2, and then we're going to divide it by 2. And that is our Cartesian equation. And I'm going to highlight all my answers. That's Cartesian, that's parametric, and that's the vector form. Okay, for our next question, we are to determine the vector and scalar equations for x over 3 is equal to 3 minus y over 2. There are different ways we can do this, but one of the ways is just realizing what our variables are and what they mean. We'll do both methods actually to get to vector form, and then from there we'll get to scalar. Here we have, if I were to rewrite this, we would have it as x minus 0 over 3 is equal to, and for the next one, since we have 3 minus y over 2, we can change that and write it as negative y minus 3, that's the top, over 2. So I'm changing this, so negative 1 times y is negative y, and negative 1 times negative 3 is positive 3. If I change this again, it'll be x minus 0 over 3 is equal to y minus 3, and I'm going to drag this negative here and bring it down to the denominator to get negative 2. This will help me write, this is like the general form for the Cartesian form, and it will help me write the vector form much easier. R here is going to equal to this point for x and this point for y, so x minus 0, it's going to go here, and y minus 3 is going to go down here. So we're going to have 0 and 3 plus t multiplied by our direction vectors. X component is 3 and y component is negative 2. This is the vector form. An alternative method of doing this is to let t equal to x over 3, which is also equal to 3 minus y over 2. We will then rearrange. So for the first set of equation here, actually, let me just do it here. We will get t is equal to x over 3, so that means x is equal to 3t. Multiplying both sides by 3 is what I've done there. And let's do this one in purple. T is equal to 3 minus y over 2. Write that here. T is equal to 3 minus y over 2. I'm going to multiply both sides by 2 to get 2t is equal to 3 minus y. I'm going to subtract both sides by 3. So I will get negative y is equal to 2t minus 3. And then I'm going to multiply both sides by negative 1 to get y is equal to negative 2 plus 3. And if we look at our equation, we can just turn this is the parametric equation. We got the x and we got the y, and we can write that in vector form. So x is equal to 3t, it means it's 0 plus t times 3. And y is equal to negative 2t plus 3, it means that it's 3 plus t times negative 2. So this is the answer to the first part. For the second part of the question, we need to write the equation in form of a scalar equation. We already have the direction vector here. The direction vector is 3, negative 2. So to get the normal vector to that, as we've done in previous question, we're going to take the negative reciprocal. So we're going to switch the 2 and the 3, and the whole thing right now is negative, and we're going to change it to a positive, so it's going to become 2 and 3. This is going to be my a value, and this is going to be my b value. Therefore, my equation is going to be ax plus by plus c is equal to 0. My a is 2, and my b is 3. Now we need the c value. To find the c value, we need a point on the line. Well, we have that. We got 0 and 3 on the line, so we are going to use point 0, 3, and we're going to plug that in. So we're going to have 2 times x value, which is 0, and we're going to use y value of 3, so 2 times 0 plus 3 times 3 plus c is equal to 0. 2 times 0 is 0, 3 times 3 is 9, plus c is equal to 0. And we're going to subtract 9 by both sides to get c is equal to negative 9. Once we have this, the scalar equation becomes 2x plus 3y minus 9 is equal to 0. And that is our final answer here. For our last question on the video, we have that K3 lies on the line with equation x minus 1 over 3 is equal to y plus 1 over 2. We want to determine the value of k. Okay, so the x value on this point is k, so that goes here. And the y value for the point is 3, and that goes here. We can write that just on the equation and just solve for k. So we will have k minus 1 over 3 is equal to, so I'm using this, and subbing in k for x, is going to equal to y plus 1 over 2, and y value here is 3. This follows that k minus 1 over 3 is equal to, on the right hand side, the numerator is going to be 3 plus 1, which is 4 over 2. K minus 1 over 3 is going to equal to 4 over 2, which is 2. I will then multiply both sides by 3, and I will get k minus 1 is equal to 3 times 2, which is 6. I will then add 1 to both sides, and I will get k is equal to 7. And that is my final answer for this.